Hello, everyone. My name is Gosai. I am a principal tester at the BBC. Just to get a show of hands, do most people know who the BBC are and what we do? Kind of, OK. So very, very briefly, the BBC is the British Broadcasting Corporation. Essentially, we provide broadcast channels, TV, radio stations, news channels, etc. But we also have a big IT side as well, where we provide apps and things like that. I'm going to be talking a lot about that side of the BBC. And for those who don't know, we're based throughout the UK. This is actually where I work. This is Dock House and Media City. And if you were to go to Media City in the northwest of England and look up at the building, that's exactly where I sit. So you see me waving back at you. So what are we going to talk about today? Today, we're going to talk about mobile automation, and specifically where we were then, where we are now, and where we're going to next. So let's start with who we are. So BBC has a design and engineering department. That's the department I work in, and we essentially work on all aspects of anything to do with engineering or design. But specifically, there are two core apps that the BBC build. One is known as Sound, which is their audio-on-demand service, and the other is known as iPlayer, which is their video-on-demand service. But both these two apps are media player systems. But the actual media playback part is actually built by a separate team, the team that I work for. Essentially, what they do is they provide the audio capability and the video capability to these two main apps. The reason for this is so that it's a modularized component that can then be reused across the BBC and other apps as well, such as the news app, the sports app, and whatever else comes along next. So where were we then? When we first started out, now this was about 6 years ago when I started with the organization, releasing and testing would take quite a while. You were looking at a minimum of 2 weeks worth of a test cycle, which could then easily take 3 to 4 weeks, depending on what bugs were found. So we thought, how can we speed this process up? And one of the first ones that came to mind was UI automation. So we went down this road, but instead of just trying to automate everything within the app, we decided, let's first understand what we're actually trying to build. And so we used the idea of 3 amigos. The amigos, we got all the developers, testers, and product owners together to understand exactly what we're going to build, and then actually go about defining what the acceptance criteria for that was. That then led on to automation, which would then hopefully lead to speeding up the release process. Things didn't actually quite go how we expected them to. Essentially, what we found was we weren't using our testers the way we thought we were. What they were reporting was pass and fail results and test cases. But when we started to dig into what they were actually doing, they were looking at accessibility, usability, performance, how our compared against our competitors. They were doing a whole lot more than what they were just reporting. They're also using this thing called exploratory testing as well, not just randomly testing things, but being very specific about what they tested, how they tested it, but very much from the end user's perspective. The automation also wasn't all it was cracked up to be. We were hoping it's going to help us release faster, catch more bugs, and generally just improve the testing process, but that didn't really happen. As time went on, we wrote more and more automated tests. The flakier things got, the worse the feedback cycle got. And because of that, our release process actually started to slow down. Initially, we sped up, but then as more and more tests we wrote, the slower things got, the more we were reverting back to the exploratory testing again. And in terms of catching bugs, at first, yeah, it caught a few bugs, but then as time went on, it got worse and worse and worse. So the fast feedback we were looking for wasn't really there. What we found was the automation engineers would sit in the corner writing all the automation code, while the rest of the team actually built the product and tested it. And so that whole idea of releasing faster never really happened. It kind of looked like it was going to give us that, but the more we wrote, the worse things got. Essentially, we got 3 main lessons out of this. What we realized was that we were using our testers as essentially a safety net. We were sitting them in the corner and saying, check that our work hasn't broken anyway. And this was possibly one of the worst use cases we could have had for our testers. They were capable of doing so much more than just running test cases all day. And via using something known as exploratory testing, they could really advocate for what our end users are seeing and how the product really performed, rather than just these random test cases that everyone thought they were doing. But in terms of getting towards releasing faster, it was actually the 3 amigos process that actually got us there. When we started running 3 amigos processes, we started to break down our work into smaller batches of releasable value, which we were able to get out to our end users a lot quicker than we were before. And that actually got us towards releasing at a faster pace, not the automation. And so from all of this, what we started to do was use our testers for what they're really good for, understanding the domain, understanding our product, and understanding how our end users use it. And in all of this, we realized that automation can't replace your testers. They're not the same thing. They can aid your testers, but will never replace them. Another thing we started to realize in this process was there was a lot of duplication going on. Our testers were testing, the automation was testing, but our developers were also running lots of tests as well. So we were wondering if there was any new ways we could actually improve this process and make use of the testing that was happening at the different levels. So that's where we were then. Where are we now? Well, as a team, we've come closer together. The developers and testers work closer hand in hand, and as soon as the developer has something they can release onto a device, the testers are getting involved straight away, and they'll go through this iterative cycle. But whenever they came to releasing, it'd actually take up to 1 to 3 days every time before they could actually make that release, and that was because of regression testing. They weren't always sure where the changes had been made by the developers and what other issues could be introduced, so we always have to go through this regression test cycle, which would vary. As I said, the UI automation was slow and reliable, so we only use that to a very small amount. In my team, we actually only have one automated UI test. Literally, does the app start? Well, does it install? Does it start? Does it do the main thing? That's it. Another thing we realized from this process was a lot of this type of testing was testing towards the end of the pipeline. You were going through the whole design process, development process, and then actually making it available on a device before you'd actually then think about testing it. So we wondered, is there anything we could do that would test this earlier on in the process and actually decrease this regression test cycle that we had over 1 to 2 days? And there's a few places we could look at. We could see what the developer's doing, and we could also look at the idea stage as well. So at the idea stage, we already had 3 amigos. This is before any code was written and anything was done in concrete that this is what we're going to do. So we had a good way of understanding what we were going to build. When we spoke to developers, they said, yeah, we do loads of testing. We do unit testing. But no one in the test team, or anyone else for that matter, knew what they did. So we asked them, what do the unit tests do? And how many do you actually have even? And they said, well, we've got hundreds of tests, look. So what do? What do the unit tests test? And this is where things got interesting. When we sat down with the developers one-to-one, they all had a slightly different understanding of what unit testing was for them. Some would say that they'd test each method. Some would say each class. Others said it was too hard. I got testers, I'm just going to use them. So they weren't even doing any unit testing. Some were hard to identify what they were actually testing. And for some, they found that it was just testing too much. They had some assertions had 5 or 6 different assertions in there. What was that unit test even testing? And from this, we realized that actually even amongst the developers themselves, they all had a different understanding of what unit testing was. So what we wanted to do was build a team understanding of what unit testing is and how we're going to do that within the team. So one of the first things we realized was the moment we said unit testing, everyone just assumed they were talking about the same thing. They never stood there and actually confirmed to one another, what does unit testing mean to you? So the first thing we did was stop calling them unit tests. So what are we going to call them? For now, we just said we'll call them code tests as a placeholder before we decide what it was. But the advantage of doing this was, as soon as you said code tests, everyone would go, what are those? Okay, well, let's go find what that is. So what are code tests? So according to J.B. Rainsberger, it's anything that can be tested within isolation within a given context. According to Kent Beck from TDD by example, is you should be testing behaviors, not implementation details. Now, unfortunately, I don't have time to go into both these talks, but these 2 talks are very much worthwhile looking at. One is J.B. Rainsberger's integrated tests are a scam, and the other is Ian Cooper's TDD, where did it all go wrong? But for now, these are the principles that we were going to stand by for writing unit tests. So we know what we're going to call them, code tests. We've got the principles. How are we actually going to do this? What architecture is going to support this kind of unit testing? Well, one that comes to mind straight away is hexagonal architecture or ports and adapters. Now, very, very briefly, essentially, everything within the hexagon is your code. This is code that's written by you and your team. No third-party dependencies, nothing else. On the outside of the hexagon are your dependencies, your back-end systems, the mobile apps that you're going to deploy to, or whatever web system it is. Essentially, the ports and adapters are at the boundaries of your hexagon. Now, again, I don't have time to go into that here, but a great place to learn more about this is from Alistair Cockburn's website, Hexagonal Architecture, but unfortunately the website is down. So I suggest you go watch Ian Cooper's TDD, Where Did It All Go Wrong, because he goes back into this again. So we've got code tests, we've got principles, and now we've got architects that can support this. Do we just go off and start doing this, or do we keep shipping our product? Now, if we went to our product owners and said, right, we want to stop development for the next 6 months while we go do this to our code base, they probably would have said no. So we had to try and balance these two things. So now, excuse the image, it is blurred on purpose, protect identities and all the rest of it, but essentially, this is a development team, this is a board, these are Post-it notes, and these are people pointing at those Post-it notes. The point of this exercise was, as a team, we got together and worked out and mapped, essentially, our whole in development environment. What is our system? How does it all work together? What are all the different parts? What's our code? What's external dependencies? From this, we then mapped it to our OKRs and roadmaps to see how this related to each other, and then seeing which of them would then map out again. And essentially, what we were looking for is, what areas of the app could we apply this type of testing onto our architecture to? What are we trying to deliver in the coming months, and how can we get it so we get what we want and our product owners get what they want? And from this, we identified ExoPlayer. For those who don't know, ExoPlayer is an application-level media player for Android built by Google. So we've identified what we want to do. How are we actually going to do it? So we know the mobile player has two core pieces of functionality. You've got the audio on demand and video on demand. And these seem like two prime areas to actually pull out and actually modularize and actually apply this architecture to and way of testing. We decided to go with audio on demand. Why? Because it's audio, there's no video involved, it's a bit simpler, and also we knew one of our product teams was going to be shipping soon, so we thought we could get some early feedback using this new way of testing and developing the product to make sure we're still shipping what we said we were going to ship. One of the things this team does is they exclusively pair. Pretty much everything they do within the team is always as a development pair. In this case, we went into a three-way mob, 2 developers and a tester. The middle space is where I sit. And essentially what we did was we grabbed the biggest TV we could, plugged in one laptop, and essentially we did strong pairing. Myself being the weaker developer, the 2 developers being the stronger pair, everything they wanted to write had to go through me. The point of that was, I then built the understanding of how the product works, but also how it's tested. Don't forget, I'm the tester on this team, so it's my responsibility to try and help the team understand what needs to be tested and what doesn't need to be tested. The great thing about this was, we started to build a team understanding of how things should be tested and what shouldn't be tested. Developers got more insight into how I tested, and I got more insight into how they were testing. And slowly, we built this trust relationship to the point where I could then eventually step out of this three-way pair, and they can continue developing the product, knowing that they already had some good practices in place. We knew we wanted to iteratively deliver this product, so how do we break this up? One of the first things we decided we'd do is just get audio playing. Let's just check that this audio even works. And then we'll go about implementing the play controls as we go along. So we've got the existing standard media player. We've worked out we want to deliver audio on demand in an iterative way, and we want to use a new ExoPlayer built by Google. The ExoPlayer is actually Google's responsibility to test and build, not ours. So only things we need to be testing are the media player and audio on demand, our integration of the ExoPlayer. So what we could have done was taken our SMP player, standard media player, put a port on it, and shoved in the new ExoPlayer. But this wasn't going to go with our iterative way of developing, because then we'd have to implement all the audio on demand features straight away, which would take a lot longer. So we decided we'd take a slightly different approach. We'll break things up a bit. So we took ExoPlayer, and we wrapped that around an interface. Call that a decoder interface, which was actually implemented by something called a dash audio on demand, and then another narrowed ExoPlayer interface, which was implemented by the ExoPlayer VOD player. This way, we completely separated our SMP's reliance on ExoPlayer. It had no idea. All it knows is if it requests this dash audio on demand decoder, it knows that it's going to get some sort of decoder that's going to play media. It doesn't know how it does it. We also implemented this narrowed ExoPlayer interface because we wanted to limit the amount of functionality ExoPlayer would give us. ExoPlayer has a lot more functionality than we needed. All we wanted, remember, was audio on demand and a couple of playback controls. It had to match the features we were already shipping with the old ExoPlayer. So we didn't want anything else that could leak into our system or anything that our end users, product teams could use. So that's our code. That's what we need to test. That's third-party code. We do not test this. That is the responsibility of the third-party dependency. If you don't trust them, don't use it. So no changes to the SMP place other than within the SMP code, other than the port that we've opened up, this is what we're going to be testing, these parts here. So how do we actually test this? Well, it's something we use. It's called fast tests and slow tests. So this is where we're getting towards our terminology of code tests. So what are fast tests? So you've got your decoder interface, you've got your dash audio on demand. This is the isolated component under test. This is our integration of the slower parts of the system. We use a test driver. In this case, these are just plain old JUnit 4 tests, so plain old Java object tests. The decoder interface describes the behavior of the dash audio on demand. This is the behavior that we're going to expose via this interface. Then we use the narrowed ExoPlayer interface, which we then use a mocked narrowed ExoPlayer. Essentially, we're mocking out our own code. In this case, never mock what you don't own. We can mock our own code because we built it. We know how it's going to work. So you can mock that. The mock narrowed ExoPlayer is a test double of the ExoPlayer V2 player from earlier. And this is actually quite a useful term to be using a test double over a mock, but I can come to that later on. So, hold on just one second. These tests are fast, really, really fast. You can run hundreds in under a couple of seconds, and you can know straight away your integration of this component is correct and working as you expect it to. What are your slow tests? Well, you got your narrowed ExoPlayer from earlier on. You got your ExoPlayer V2 player, but this time you're actually really integrating the ExoPlayer. But don't forget, our job is not to test ExoPlayer, just our integration of it, and this is what we're going to be testing. It just so happens to be the ExoPlayer is there. And we use a test driver. In this case, we're using plain old instrumentation tests to actually run this. So when our test driver goes, play this piece of media, the ExoPlayer is going to try and obtain that piece of media by calling out to the internet. This is when we jump in with wiremark and go, here you go, run this piece of media instead. This is our slow test. This tells us, does the audio player integration actually work correctly? In this case, some audio is actually going to play. And so what we found was we could actually deploy this to an APK and then put it on a real device and actually hear the audio playing out. Internally within the BBC, we built something called Hive CI, which we spoke about at our previous droidCon conference back in 2015, I think. So there may be some videos on that kicking around. But essentially what we're able to do is deploy this to numerous different devices, see how it works there, and then actually implement it into our racks as well. So this was all completely integrated into our development pipeline. These tests are slow because you're actually testing real audio playback. So they can take nearly a second or even 30 seconds in some cases to actually run. And so you wouldn't want to run these all the time. But one advantage is you get to actually deploy these to real devices so you can see if this integration of the ExoPlayer is actually going to work for you and your devices. But don't forget, you narrowed down the test cases. You've used a very specific context in which you're testing. So when you integrate all this together, you've got a pretty good idea this is all going to work because you've tested this in two different ways. So now you've got your audio on demand with ExoPlayer, integrate into SMP, and then you can deploy that via something that we use internal, which is our test harness. Then you can deploy that to a real phone, and this is where our testers really get involved. So the idea here was, as a three-way mob would build the tests, I'll be there coding the code-level tests with them, but then as soon as we can deploy it to a phone, we then actually pick up physical phones and actually make sure, can I hear audio coming out? Are there any other use cases? What happens when it hits the Wi-Fi network? What happens when it hits the cellular network? Trying all sorts of different use cases as we went along and seeing where the problems were. Because we'd broken out our development process into two, fast and slow, we could isolate very quickly where the problems were and write the test at those levels when we found bugs, and then move on quite quickly. And again, we were using exploratory testing at this point to then iteratively deliver all the features that we wanted as time went on, while still shipping this to our end users. So what does this give us? It's testability. You're now delivering small batches of value. Our product teams could implement this whenever they wanted just to see how the new ExoPlayer is going to work for them. But also using better use of our testers. We're not just getting them to sit in a corner running tests all day, but actually getting them to be very specific about what they were testing, what they weren't testing, what levels were tested at the code, and what still needs to be tested at device level, and what wasn't already covered by the different areas. So they're being very specific about what was being tested now. So that was now. We've got our code tests, we've got slow connected tests, and fast unconnected tests. Back to our two principles. So we've got our development environment. The context within this case is audio on demand. The isolated components are the fast and slow areas of the device. So anything that can be tested in isolation within a given context, check. Don't test implementation details, but behaviors, check. We're only testing the interfaces, not the behaviors of those components. So we've carried out 2 of our principles as well. How are we going to hexagonal or ports and adapters architecture? Well, we've got SMP, because we've opened up a port on that, and we're fitting in the new decoder, we've now started heading towards this hexagonal architecture and spreading things out a lot more. So what's next for the team? Well, we've got audio on demand. What about video on demand? Well, that should hopefully be a bit easier this time. Now we've laid a lot of the groundwork for audio on demand. It should be a matter of creating a new video on demand decoder interface and actually expanding the narrowed ExoPlayer to reuse that. We could either bank what we've already tested, or we could extend it. It's up to us how we want to go about doing that. Another thing that we got is SMP is actually integrated into our product teams, which we release into them. They then give us feedback to let us know whether or not it works or not, which they then release to their end users, who then feed that back to them. So our feedback cycle can be quite broken. Here it's fairly quick, as these teams are on the same floor as us, but these guys, we have no idea what they want or how they're using it. So we have to wait for that feedback to come back to our product teams before we can integrate it into ours. Not only that, we then got one product team and then another, whichever comes next. And so this problem gets bigger and bigger as time goes on. But that's fine, because this is only our problem. This is the product team's problem here, so we can probably not worry about that too much. Unfortunately, things have changed a bit since I last did this talk. I used to work for this team. I now work for these teams here. And not just one of them, I work across the whole department. So now this is very much my problem. So we're starting to look at new ways of testing this. And so I need to do a bit of a slide switch. So one of the ways we could actually try and address this problem is using contract testing. Now, the thing with contract testing is most people only ever see this in the web world, but you can do it at the component level as well. But one thing we found was when we mentioned this to testers, developers, or anyone for that matter, again, everyone had slightly different understanding of what they meant. So we thought, well, let's go through a bit of an education process here and figure out what is contract testing and is this something we can use. So first in terms, there's consumers, so in this case, the product teams, so things like iPlayer, Sounds, whoever it is, whatever your product is, you're a consumer. We've also got the providers, who's providing you this third-party service. It could be someone outside of your company, someone internal to it. But essentially, there's consumers and providers. And what you do is you don't talk to them directly, you go through a wrapper or an interface of some sort. No changes in consumer. The provider is not your responsibility, so the thing you're going to be testing is your integration of that of that provider. So how do you actually do this? So again, in a very similar fashion as before, you got your abstraction, you got your test driver, and then you got your test double. Now, what's a test double? It's essentially a stand-in for the provider. Now, I don't have time to go into that here, but you can ask in the Q&A later on, and we can talk more about why making this distinction here is actually really important to the team. But essentially, this is the isolated component that you're going to be testing. This is the point of this. But what are you testing? And this is 3 very specific things. You're going to be testing, does the API exist? Your compiler is going to do this for you very simply. But does it respond? It's probably not going to do that. That's going to have to be tested for. But your final test is going to be, is it in a recognizable format? You're essentially not testing what is the actual response, but does it respond in the way that I expected it to? So if the API is meant to respond to some Java object or some JSON file, it actually does that. But that is as far as you go. You're only testing your integration of this, not the actual behavior. There's also a problem known as the test double drift. Because you're using a test double, there's a chance that your provider actually changes from what your test double is. So how do you address this? Very simply, you got your SMP abstraction, you got your test driver, and then you got your provider, and you test against that. Again, using YMark to mark out any backends. Now, you could argue, why not just test this way? This is a lot slower, and this way you're making assumptions about your provider, and testing via YMark or whatever backend you're marking out is going to tightly couple your tests together. These tests here are simple and easy to understand. If you write any more tests in this, or you start testing the behavior of the test double, they're no longer contract tests. You've headed into functional testing at this point. Don't call it contract testing. So what benefits are you getting from this? Well, This way, it makes consumers think about who and why they're using those providers. Why have we got them here? What are we doing with them? You're also increasing testability of the system now, because you're actually defining exactly where you're integrating and what integrations you actually need for it. You also got executable tests over documentation. Before, you could have just had an API doc that just said, these are all the APIs we're using, but now you actually got tests that you can run against it and actually run through that whenever you want, how often you want. You've also got isolation of providers now, because you're only abstracting away and using them for one specific area. What are the costs of testing this way? Well, your tests need to be strict. If the moment you step away from those 3 core main areas, you start heading into functional testing. So you need to be really strict about what you're testing. Unforeseen testing issues. Because of the test drift problem and all the other issues that you can get, there could be issues when you try and test against the actual provider. This is not a substitute for end-to-end testing. Don't forget, you're only testing your integration of the component. You still need to do some level of functional testing to understand exactly how this provider works. The provider also, at this point, gets no insight into the consumer's usage. All they know is that they've provided this component and someone out there is using it, but how they're using it and what they're using it for, they have no idea. So is there any way this could be addressed? There is, and it's quite simple, and it's known as consumer-driven contract testing. Now, this is quite slightly different to contract testing. So in this case, you've got your tests that are written by your consumer team, and this is maintained and built by them. They then take these tests and provide them to the provider's team to run within their pipeline. Now they can see exactly who the consumers are, how they're using them, and also what APIs they're calling. And that starts giving some more insight into who the consumers are. This also starts a conversation between the consumers and providers and says, this is what we need from you. These are the contract tests that you need to adhere by for us to be able to use your product. If it doesn't do this, we're in trouble. So now iPlayer provides their contract tests, and so do the sounds teams and so on. You'll also notice there's some duplication going on. So one of the things the provider teams could do is provide the SMP test double to all the other consumers. And now they could potentially do some more testing. And it stops that test drift problem we had earlier. So what are some of the benefits of this? The provider team now gets insight into the consumers. The consumer teams get early warning of any breaking changes. Has the API call changed? Does it still respond in the same way? Are there new APIs? Are there any other problems going on? You further decouple the providers and consumers. Then now you don't have to integrate the same consumers and providers. You separate those out and test them at the same time. You've still got all the benefits of contract testing. Some of the costs, you need a way to share the tests. Now, this is okay if they're all internal to your company, but if they're external, how are you going to share the tests with them? You're going to give them access to your Git repos? Who knows? The provider teams need to make their tests visible to the consumer teams. It's already well if you provide the provider team all your contract tests, but who knows if they're running them? So they need to build that transparency around what tests they're running and how they're actually running those within the teams. One of the things with consumer-driven contract testing and contract testing in general is that it's not a replacement for conversations. It's a way to facilitate them. You've now got a way of talking to each other. As a provider and as a consumer, you can now tell your providers, this is what we need from you, these are the tests we need you to adhere by, these are the contracts we need you to be running against, but also your providers get insight into who their consumers are, how they're using them, what they're not using, and what could break if we make any changes. So now you've got a way of actually talking to each other and actually facilitates that discussion. So that kind of takes us towards the end of our talk. That's kind of where we have been then with automated UI testing, where we are now with unit level tests and how we're actually talking about those unit level tests and actually building a team understanding of it, but also what we're looking at next. We're looking at contract testing and consumer-driven contract testing. We've only just started this journey, so we're still trying to work out whether we're going to do contract testing or consumer-driven contract testing, or none of the two. Maybe we'll go down a different road altogether. We're also looking at things like synthetic testing, as well as what we're going to do with modularizing our system and what all the version problems we're going to get. So that kind of brings us to the end of our talk. Thank you very much.